In this section, we're going to talk about some graphical representation for qualitative data. And actually, in this whole chapter, chapter 2, we're going to talk about multiple graphical representation between qualitative and quantitative data. But in this section, we're mainly focusing on qualitative data. So let's go over some definitions. So the frequency of a category is the number of times it occurs in your data set. But a frequency distribution is actually a table that shows the frequency for each category. So let's look at an example. So let's say you're a physical therapist and you took a random sample of 30 of your patients and you ask them about which body parts needs some work. So you have this raw data set, and notice that this is all qualitative variables. So you want to create a frequency distribution. So how do we do that? So you want to actually list all the body parts that's in your data set. So there is back, neck, wrist, ankle, hip, and knee. So let's look at back. So you have to kind of tally all of the back in your data set. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 backs. And you want to tally them up. So there's 10 backs. And you kind of want to do the same for the rest of them. So for neck, there is 6. For wrist, there's 3. For ankles, there's 4. For hip, there's 2. And for knee, there is 5, right? And you kind of want to check to see if you did this right. And one way to check is if you sum all of your frequency, and if it matches the number of sample or the number of items in your sample, then everything is counted for. So if you add 10 plus 6 plus 3 plus 4 plus 2 plus 5, this gives you 30, and that means you're on the right track because there's 30 patients in your data set. So everything is okay. So this is a frequency distribution, and it kind of tells you how often that each category pops up in your data set. But that doesn't really tell you a lot, because what a lot of people want to know is, what does this number mean in respect to everything else? So what is the proportion? So that actually tells you a lot more. And what often people do is make a relative frequency distribution, which we're going to go over next. So here's a little note about what a relative frequency distribution is. So let's go over some definition. So a relative frequency is just the frequency of that category divided by the sum of all the other frequencies. And a relative frequency distribution is very similar to what we did earlier with a table, but just with an extra column. Another thing that we should notice is that that column, if we add them all up, it should be equal to 1. Okay, so let's construct a relative frequency distribution from the previous example. So we had back, neck, wrist, ankle, hip, and knee, and this was 10, 6, 3, 4, 2, 5. All right, so for a relative frequency, remember this is the frequency of that category, which is 10, over the sum of all the frequency, which is 30. And this is roughly 0.333, roughly. Similarly, we kind of do the rest for them. This is 6 over 30, which is 0.2, 3 over 30, 0.1, 4 over 30, 0.133, 2 over 30, 0.067, and 5 over 30, 0.167. Notice that I kind of round in 3 decimal places. That's kind of like the rule of thumb in statistics, is that we always do 3 decimal places or round to 3 decimal places if it's not stated otherwise. One thing to double check your answer is that if you take the sum of your relative frequency, it should be equal to 1. So 10 over 30 plus 6 over 30 plus 3 over 30 plus 4 over 30 plus 5 over 30 plus 2 over 30 plus 5 over 30 should give you 30 over 30, which is the same as 1. Also, if you take the sum of the decimal, and if you have something like 0.9999, then that kind of tells you that there's some sort of rounding error. Okay, so something to keep in mind. All right, so let's look at a bar graph. So what is a bar graph? It's actually a graphical representation of a frequency distribution or relative frequency distribution, depending on what you're working on. So something that you should note about bar graph is that each category has its own rectangle or bar. The bars are of equal width and equal space. One thing, very important, that in a bar graph, the bars cannot touch each other. If they do, they become something different, and we're going to talk about that later on into the chapter. The height of the bar represents the frequency or relative frequency, depending on what we're working on. And bars can be vertical or they could be horizontal. Also, one important thing is that when you're making a bar graph, make sure to have a title and label your axis. Because if you just give me a random bar graph, I wouldn't know what it actually represents. So let's look at some examples. So let's create a bar graph using the frequency distribution from the first example. Okay, so first thing you want to do is kind of put the labels of all your categories. So we have back, neck, wrist, ankle, hip, knee. Notice that they're all equally spaced out. Just a reminder, we're working with a frequency distribution. So let's label our axis, which is 2, 4, 6, 8, 10. Notice that I haven't have a giant leap. So I didn't go from 2 to 8 to 15. They're all kind of equally spaced. So that's a little note there, that they should all be equally spaced. All right, so let's kind of label our axis here. So here on the x-axis, let's write body parts. On the y-axis, we're going to write number of patients. Here on the title, let's write body parts requiring rehabilitation. Okay, so let's actually draw our bar graphs. So here, we know back there were 10 that show up in our data set. So we go up to 10. For neck, there were 6. For wrist, there were 3. Ankle, there was 4. Hip, there were 2. And knee, there were 5. And this is how you draw a bar graph. Okay, so we're going to do the same thing, but with the relative frequency distribution. So again, let's put in all the categories. So we have back, neck, wrist, ankle, hip, knee. And notice that again, they're kind of equally spaced out, which what we want in our bar graph. Here in our y-axis, we have 0.05, 0.1, 0.15, all the way up to 0.35. Notice that I'm not jumping really big. Like I'm not going from different spacing. I'm increasing everything by 0.05. And that's something to take note. Here on the x-axis, we'll write body parts. And on the y-axis, we'll write proportion of patient, because we're dealing with relative frequency. And then our title should be body parts requiring rehabilitation. Okay, so let's actually draw our little bars. So here at back, remember, it was 0.333, so somewhere around there. For neck, it was 0.2. For wrist, it was 0.1. Ankle was 0.133. Hip was 0.067. And knee was 0.167. So next we're going to talk about Pareto chart, which is basically the same idea. We're just rearranging our bars in which it's decreasing order. So on our axis, we're going to write 2, 4, 6, 8, 10. We know that back was the biggest out of all of them, so that'll go first. And followed by neck, which was 6. Followed by knee, and ankle, wrist, and hip. And just to take note, we're working with the frequency distribution table. And hip, right. So idea is just rearranging our bars in which it was decreasing order. And then we have to write our axis and our title. Okay, so next we're going to talk about side-by-side bar graph. And usually when people do side-by-side bar graph, they usually just want to compare two bar graphs that have the same category. So each category has two bars, and they do touch. So for example, let's say you want to know how many people go to a specific website for 2 different months, November and December. So you have all this data and you want to compare them. So what you do a side-by-side bar graph. So how do we do this? So let's look at this table here. So we want to write down our categories. So it's Google, Facebook, Yahoo, YouTube, and Wikipedia. And on the x-axis, we're going to write 25, 50, 75. So notice how, again, I'm not jumping from 25 to 100 and 100 to 125. They're all equally spaced. Okay, so let's write down our x and y axis. So we have websites and the number of visitors. And remember, this is in millions. And our titles, let's write number of visitor in each website. Okay, so let's start drawing our bars. You know, Google in November, we have 157. And December, we have 173. In Facebook, we have 147 on November. And on December, we have 166. So similarly, we kind of do the same thing for the rest of them. So it's the same pattern. Yahoo would be 146 in November and 164 in December. We do again with YouTube and Wikipedia. Okay, so lastly, another way to graphically represent our data is something called a pie chart. So a pie chart displays our relative frequency in a degree form. And how do we do this? So let's say you have this some sort of data and you already done the frequency and relative frequency distribution. So you want to convert this into sectors, some sort of degrees. So these degrees will be the degrees of each sectors. So how do we do that? So let's look at the first one. So we know that in a circle, there's 360 degrees. So all we have to do is do 360 times 0.22. And this 0.22, I just got it from our relative frequency distribution. And if you do the math, this should be 79.2, but we could actually just round this to 79. So for the second one, it will be 360 times 0.46, which is 165.6. We could just round it up to 166. And then this will be 360 times 0.18, which is 64.8, but we could just round this up to 65. And then this will be 360 times 0.14, which is 50. So next, you kind of want to match each sectors from its rightful category. So how do we do that? We kind of look at the biggest sector and look at the biggest degree, and they should match up. So in this case, 166 is the biggest, which is Visa. So this sector here should be Visa. So this is Visa. Then we want to look at the next biggest, which is the blue one here. So it should be 79 degrees, which is MasterCard. And you kind of want to do that for the rest of them. So this sector should be America Express. And then finally, we have Discovery, or Discover. And we can ask a couple questions with this pie chart. So visually, we could see like the most popular one. In this case, is Visa. And we could look at the least popular credit card, which is Discover.